Hey, it's great to be here again this year. It's really awesome, and it's great to see a lot more people. It's always awesome to see all the familiar faces from over the years building Web3, and it's great to see a lot of new faces. So I'm really excited that this event continues to attract lots of new people and making the movement a lot stronger. So a huge round of applause for the organizers of the event, because this is awesome, and I wanted to keep going every year. We have a lot to talk about in the next 20 minutes. I won't go too much into detail about what Web 3.0 is. Let's suffice it to say that it is the next evolution of the web. It makes the web read, write, trust, trust being the operative thing there, and it's achieved through verifiability and a whole bunch of primitives that build up to that. If you're new to Web3, you may want to check out the talk I gave last year, which goes over the movement in general and talks about kind of the principles behind it. I do want to talk a little bit about some values. So this is just one take at a set of values that I think a lot of the people here will agree we hope Web3 will represent. You might not agree with all of these. You might not agree with, and you might think that there's a bunch missing. Sure. Side note, we should probably create a set of the agreed upon values of Web3. I think that'll help us make things together. But as you think about these items, consider how computing took over the world and how quickly that happened. Think about all of the devices that you carry and that people all over the world carry right now in this moment, where I think the average now is something like 1.5, maybe in the future it'll be 2, we'll see. Think of the big changes that are coming with virtual reality, augmented reality, brain-machine interfaces, AI, machine learning, and so on. A lot of things over the next few decades are going to change radically, and people will use the amazing superpowers of computing for good and bad. And so thinking back to these values, I think it's really important that we bake a bunch of these things into the network while we can. Now, the interesting thing about these values is they tend to map or at least relate to some systems. So you can think of things like freedom of speech and achieving that through making systems that enable secure data publishing and distribution. You can think of achieving things like reader and writer privacy through making things like oblivious content routing and so on. So for whatever list of values we generate, we should be able to come up with a corresponding set of systems. And ideally, we can prune that and reduce the number of systems that we need to build, because, hey, building less is probably better. And that way we'll achieve the set of building blocks that will make up Web3. A lot of us are already doing this. I think that there's a whole bunch of interoperability and integration that's missing, as we're getting much better about it now, but there's still a lot to do there. But the thing to reflect here is some of these things are going to take a long time to get right. Especially when you think about reader and writer privacy, just that one thing alone is extremely difficult to achieve. And it'll take us a while to build systems that will work with the applications and the UX guarantees that you want, meaning, hey, the page should load quickly and so on, and do that in a reader and writer privacy safe way. This kind of stuff, it will take a bit of time. And so I strongly encourage you to see what values you care about and what systems don't yet exist, and go build them so that we can make a much better web. So the cool thing about Web3 is that the movement is now organizing around a set of building blocks and kind of organizing a stack. And so you'll hear a lot about all the different kinds of things that are being built throughout the whole conference. And just map them back to this stack. And hey, maybe the stack will need a pull request at some point, and maybe this will improve. Encourage you to contribute to that. And I'm here to talk to you about a number of the building blocks that we're working on. So obligatory building under construction GIF. Who remembers these from the 90s? Great. So I'll talk about IPFast first, and I'm not going to give a strong introduction to this. I will assume that either you have heard of them or you can look them up online later. I'll just refresh your memory with a pithy one-liner, like IPFast makes the web work peer-to-peer, and a nice, handy illustration. The whole point of IPFast is that it just achieves this one thing and does a whole bunch of work to make this one thing work well, which is mapping addresses on the network to content addresses and addressing all of the data with cryptographic hashes. Easier said than done, but it makes the web a lot better if you do that. So what's new? This is the more interesting part. The biggest thing that I want to highlight is that IPFS grew a lot since the last time I was here. The network grew about 30x earlier in the year, just kind of very suddenly. And there's now like hundreds of thousands of long-lived running nodes in the public network that we see. There's other networks that we don't see. And so this is pretty cool. And it continues to grow every year. So maybe next year we'll be an order of magnitude larger, hopefully. Or not. Sometimes the network, we've seen the network go up a lot and down. So we'll see. We also get to see some amount of traffic through our gateways. So we run a public gateway for some of the traffic coming through HTTP. And we see about 3 million requests per day, which is a lot for decentralized web kind of systems. This stuff is still very new. So the community that we're part of and the things that we're building are still very small compared to the rest of the world. And I was actually impressed that these kinds of numbers are there. Also, IPFS-powered applications have millions of monthly active users. I was like, what? That's pretty awesome. And there's a whole bunch of, there's a lot more applications every year. So hopefully this map is going to get so big that you won't be able to look at a logo because it'll be like a pixel. A cool notable thing that's been happening is that there's a bunch more gateways springing up, and that's good. We're running the gateway as kind of a service for the community, but it's better if a lot of other groups that need to use a gateway for a lot of traffic run theirs. Side note, caveat, make sure to use the canonical addressing. It's a whole other thing. Gateway is meant as an intermediate step to getting full interoperability of the protocol in browsers. Probably the most notable gateway is Cloudflare's gateway. So that was a pretty interesting and awesome thing that happened where Cloudflare created an IPFS gateway, and this is one of the normal kind of broader internet players actually getting pretty interested about Web3 and trying to experiment with a lot of this stuff. So we'll find a bunch of allies in the current networks and so on, and it's especially good for us to identify companies whose business models aren't the Web3 non-compatible business models and help build a faster movement by bringing them along. Yeah. So the other thing around this is pinning services. So this is a pretty cool development as well, which is a whole bunch of groups are starting to run services where you can pin your IPFS data. Pinata, Infura, Temporal, and a number of others. Another great thing is there's a bunch of developments in IPFS in browsers. So number one is that IPFS Companion, this extension that you can run and that just will render your stuff, is now in 20,000 people are using that, and that's like, what? This was a small tool that that a community member who now is works on IPFS full time just made, and this is I'm still impressed that that many people will run an IPFS node in their browser embedded in there. Another really cool thing is that a bunch of browser integrations are happening. So one is Brave Nightly supports embedded JS IPFS running an IPFS companion, and that's a pretty cool development, and it'll allow resolution of the protocol. And that's exactly what we want to drive through, right? So the gateway and companion and all these other things are sort of stepping stones to get to this. This is what we want. Opera is working to add IPFS and ENS resolution through either a gateway that they'll run, or if there's kind of a local service running companion or desktop or something like that. And Firefox now supports supports decentralized protocol handlers since Firefox 59. So that's pretty sweet. And libdweb is being integrated into the browser engine. So all of this is really, really awesome developments of the larger groups adopting and getting into the Web3 world. Also cool thing to note, there's a number of human readable, so we get a lot of flack for having hashes as names. Understandably, hashes take a long time to type, and they're really hard to memorize. So of course, it's very nice to have good-looking names. Things like ENS, and there's a number of others are integrating, so that's really cool. Also, IPFast Desktop, which is a tool that you can just download and run, is like a nice, if you don't want to install your daemon yourself and so on through the command line, which is the main use of IPFS. So this to me is a good sign, which is people that don't use the command line as their main thing are starting to get involved in all these protocols, and like that's surprising. But probably the thing I'm most excited about is mobile. So finally, IPFS has come to mobile thanks to the great efforts of a few groups. And I'll highlight Textile, which is building a whole platform for building applications on top of IPFS. And they've done an amazing amount of work to build a whole SDK where it's pretty easy to build an application and deploy it and to do all of the content encryption and some amount of the content distribution. And yeah, highly recommend going to check out their examples, and just you can download them. They're all open source, and you can play around with them. So really, really awesome. Also, Haven from the OpenBazaar team, or OB1 team, is this new mobile app that just shipped. You can download it now. It's really, really snappy, and that runs an embedded IPFS node in your phone. So the Web3 is coming to mobile. Another one I'll mention is Birdie. This one, I believe, is not fully out yet, but it's really cool. It's a messaging. And the cool highlight here is that they're implementing Bluetooth transport for IPFS and libp2p and everything. So that's going to be awesome. So once Birdie lands their Bluetooth transport in libp2p, then IPFS will work here locally without having to talk to the rest of the world. And all users of libp2p will get that too. So if you're building on libp2p, you'll get that. So awesome. Also, something that happened earlier in the year is that we had like a big IPFS camp together. That was a really awesome event that pulled a lot of us. And this was highly recommend, if we run this or something like it in the future, come join us. And we have a large community forming around Protoschool, which is a set of chapters around the world where people meet and go through tutorials or workshops and so on to learn about IPFS and a whole bunch of other Web3 technologies. Great, shifting gears to libp2p. libp2p is a modular network stack for peer-to-peer protocols. Probably, I think this year we're basking in the sunlight of having the awesome Rust libp2p implementation be built last year. All of that amazing work has translated into a whole bunch more of adoption and interest in libp2p. And yeah, the adopters list keeps growing. Probably most notably, Ethereum 2 is strongly considering, or almost on the edge of using libp2p. At least that's one of the main things. And they've actually done a bunch of work to fund the development of a whole bunch of implementations. You'll hear a lot more about libp2p from Mike later in the week, so highly recommend you go just watch the whole talk about and give you a much larger overview into the system. I'll mention one thing that happened recently, which is the whole IPFS growth made the DHT resolution for IPFS much worse, and so that was driving was bad for IPFS because things were slower, but the good news is that it drove a lot of our attention to make all of that stuff better. So it's driving significant improvements in connectivity. So things like, hey, forcing moving to Quick faster. We already have Quick, but making it a default is stuff that we're considering. Looking into dialing, making that much better. Doing the whole packet, moving to building packet libp2p first and so on. So we're considering all these things. And most notably, we want to invest very deeply into large-scale network testing. So if you find Raul around sometime during the conference, you can talk to him about that. You may be able to use the stuff we build for your protocols. Great. So one other thing I'll mention is plug it now. You'll hear more about later. There's a whole bunch of libp2p dev grants, and there's some bounties for later in the week. So check those out. Shifting gears to Filecoin. Filecoin is we want to make a decentralized, efficient, and robust foundation for humanities information. There's a lot that goes into that around markets and so on. You can think of it as a network like this, where there's a whole bunch of data providers and a bunch of clients, and you want all of the transactions to work just fine, even if the parties storing the data or the parties requesting the service are malicious or rational and so on. Rational meaning they'll go for the best monetary outcome, but they won't necessarily care about following the protocol. I'll mention a few key things. Number one is earlier in the year, we opened up a whole bunch of repos and started the community. We had been kind of developing in kind of a closed mode, but we now shifted that to open. And we pushed a whole bunch of live devnets that you can play around with. So you can now download the code and connect to the devnet and play around. There's an even stronger version of that coming soon, where we'll now have a long-running devnet that will upgrade over. Right now, we kind of shut down the entire network and switch whenever we kind of upgrade the protocol. We're now moving to, soon in the future, we'll have another release where it'll be a long-running network that will just update. So getting that working really well for the protocol is pretty important. We've had a bunch of ongoing releases, and the dev community is growing. I think now we have over 100 contributors, and this is our roadmap. Like we're full steam ahead, driving towards testnet. Pay attention to Filecoin development, download the code, help us sort out issues and so on. Anything you can do to help us notice stuff faster will get us all to Filecoin sooner. And I think one important thing we wanted to highlight today, and we're announcing this today and opening it up, is Filecoin Dev Grants. So we're introducing a number of grants for all kinds of stuff from core development on the protocol. So if you want to work on the actual implementation that we have going, or you want to write a new implementation, I'll talk a little bit more about that in a moment, or you want to develop applications on top, or you want to write tools and libraries, do technical design, documentation, all kind of stuff, there's some dev grants that we're opening up. And the first round is the first wave is gonna end in September 30th. So please go check out the repo and apply there. So I want to talk a little bit about funding more implementations of Filecoin, because it's really, really important for these networks to be as resilient as possible. If you consider a whole code base as a bug, as something that has some probability of having a bug, and you think of different implementations as potentially not having the same bugs, then very quickly you land on the spot of wanting to have as many implementations as possible. And so if you implement one protocol, like say 3 times, and you draw some very clean boundaries, then you can actually start recomposing the implementations and get some like synthetic combinations of implementations. And the really cool thing about that is that it can, though it messes with the independence of the potential problems, it very likely makes the network much more resilient. Because some of the kinds of attacks that happen on these networks is that somebody spots a bug that will crash one implementation, and so they'll exploit that, and then they'll exploit some other bug that actually tries to do some like broader harm in the contracts engine or something like that. So with that in mind, we are seeking a bunch of other groups to implement Filecoin as well in other languages. So if you or your org is interested in this, reach out. And great, so there's a lot more stuff that I would like to talk to you about, but not enough time. We have a bunch of other projects, and we're doing a bunch of research that is now diving into just fundamental crypto work, where like now we're publishing crypto papers in like ePrint, and like that's really, really awesome result with our team. And there's a lot of us around this week, so just find people from these projects or from PL and talk to us. We can tell you a whole bunch of stuff about all of these systems. I wanted to end with some reflections about the building Web3 just moment as we're all gathered here, and we're going to talk for the next few days. I wanted you to know that, number one, we're making great progress. So I was just stepping back and looking at everything that's going on in the ecosystem. There's a lot of stuff going on. Every year there's a bunch more applications. And if we had a roadmap for Web3, hint, let's make one. My guess is that we would be advancing with very high velocity through all of those goals. The kinds of things that you would have liked to do, say 2 or 3 years ago, that you can now do is quite high. So just as a note, it's awesome that we're making great progress. It's easy to get disillusioned in a lot of these moments when you're building new technology, because the thing you're working on isn't yet deployed to the rest of the world, or the thing that other people are working on you see is like not yet everywhere. And it's especially frustrating when you think back to the social networks that like went from a few thousand users to millions to like billions in the span of a year and a half, right? So the Web 2.0 world that took advantage of a decade of infrastructure building before isn't where we're at. We're had to build a whole bunch of new infrastructure, and when you look at a lot of the protocols that you'll hear about this week, there's some extremely difficult, complicated stuff going on there that'll take time. So given all of that, I think we're making pretty great progress. I think, so every year I kind of think through the scale of impact, and I would grade us as being here right now, which is pretty great. I think I would have guessed we were lower, but I think we've now reached this boundary. I think the first applications that are starting to potentially impact many tens of millions of users are out there. It'd be great if next year when we gather, we're like 1 order of magnitude higher. And if we do this every year, then it doesn't take that many years to get to the whole of the world, right? So let's power through. Then the number 2 thing I wanted you to remember, which is related to this, is stay on target. There's a lot of amazing stuff going on, and I've seen just a lot of groups, and it happens to us too, where we're working on a bunch of things and we're focused on kind of nailing that, and then suddenly we get distracted by this fancy new shiny potential project, and we're like, oh cool, let's go work on that. And so what happens is the entire ecosystem goes and builds something and is like half baked, and they move on to something else, and then something else, something else, and we've just created and littered the GitHub with all of this stuff that is just half finished. And because of that, we aren't getting to where we need to. The second part of this is, hey, remember that like the internet and hypertext took a very, very long time to get to the goals. And so when you think about back to the values, you'll hear a lot of people talking about things this week that will seem to you just not feasible, not possible to do this year. And that's OK. It's great to have the beginnings of systems that will come into existence, say, 2 or 3 years from now, as long as they don't hold back everything. So. Yeah, stay on target, ship your stuff, try to make it as incremental as possible so that we can all take advantage of it. And then number 3 is we must make Web3 way, way easier to develop. Right now it's damn hard. And I want to talk about a few items here. Number 1, crypto systems are very hard. Think about like all of the carefulness that people put into doing things like shipping new ciphers and things like that. People were terrified if you were going to ship a new untested or cipher that had been around for a few years, but nobody had like really deployed on a large scale, and you would be branded crazy if you would to deploy some like new crypto like that. This nowadays, you hear about a new fancy crypto system built on top of a stack of other crypto systems that all came out in the last 2 years, and people are deploying this and putting hundreds of millions of dollars at stake on them. And that's super crazy, right? Like, it's happening and it's succeeding, but at the same time, it's very risky. So just remember the crypto systems are very hard. We need better tools to reason about them, and contingency plans if there's a cryptographic break on some of them, to make sure that things are safe. Even you can detect a failure and then recover from it. The second thing is that peer-to-peer systems are hard as well. So the only thing harder than a distributed system is a distributed system you don't control. So you can't actually deploy things when you want to. You can't shut things down when you want to. Machines are out there. They're going to do whatever they want. They're going to potentially attack you. All kinds of things are going to go on. And you have very little observability or reproducibility. And by the way, tons of systems just won't use the applications or the platforms and devices that you want them to. Also, economic systems are hard, and we're all building extreme applications with amazingly complex economies, and we're doing very little to analyze and simulate these things. A lot of groups are trying really hard, but I think it's just not nearly enough to the degree at which we really should be, given the amount of value and importance that these systems will have. Because even if something doesn't go wrong, you have now built an economy that is going to if it's successful, it's going to now rule over a whole bunch of people and programs and so on in the future. And whatever system you put in place is now going to take effect. So if you are pissed off about the ills of the modern economy and the current way in which the world ascribes value to things and are frustrated about how we're not doing anything about climate change, well, hey, you're now building an economy and you're not doing the same thing you're frustrated about, which is we haven't really thought through all of the components, and you damn well should. So this stuff is really, really hard, and we don't have good enough tools. So I think what we need to do right now as a whole system of people is to invest deeply in making drastically better tools to make all of these things easy. It doesn't have to be this hard. We do all kinds of things these days that were extremely hard on this level of complexity, but we use computer science to make them way easier. Think about manufacturing chips. That used to be extremely difficult. Now it's much easier thanks to computers. So, all right, this is why development is too slow on a lot of the things that are going on. So I think like the suggestions, I'll give you some suggestions, and then I'll walk off the stage because I'm over time. For crypto systems, I think we should think much more carefully about protocol parameter modeling. So things where you use computers to actually understand what the parameters really should be. I've seen a few groups doing that. We're doing that. But this should be a pretty standardized thing. We should do system composition risk analysis, where you're starting to use a bunch of crypto primitives, and you're composing them into other systems, and then you're giving this package to somebody else, and they're doing that too. And you're just hoping that everyone read all of the warning labels on all of the very dangerous crypto primitives all over the place. And hey, guess what? They probably didn't. And so what we really need to do is make this a computable thing as well. And with that, I think we need to make compilable protocol specs. So, and we're probably, among the bad offenders of the entire ecosystem. We don't have good enough specs. And beyond that, they shouldn't be human readable. They should be, but in addition to that, they should be compilable. We should have computers tell us whether they're right or wrong. So we're working on these kinds of things as we develop Filecoin. But I think this is a broader ecosystem thing that needs to happen. And so some of the things that we're thinking about is like automated test suites, where like you have a spec that's computable and you have spec tests associated with it, and then you can test all of the different implementations. This will take a while. Or when you think about composition of systems, you'd like to be able to see what the configurations might be. You'd like to understand what the single points of failure in your system are, and if you have alternatives, can you switch from some system to another system if it breaks? Or at least understand what it is. And when somebody uses it and composes it into something else, they understand what it is. So for peer-to-peer systems, developer tools, observability and introspection, anonymized usability metrics. This is a really important one. And then testing with real and large-scale networks. So this is an example tool that we're making for debugging our DHT, like really understanding, like using Chrome DevTool style visualization of what's going on. So make these things. I'm sure that you're encountering things like that you need to make tools for, so do it. All right, these things as well. This is probably the hardest. If you can do this, awesome. If you want to do this, come talk to us, because we really want this to exist. But I think this kind of stuff is going to take a long time to really develop and be fleshed out. But we're super interested to work with people that are interested in modeling and simulation of large-scale economic systems. So if that's your jam, come talk to us. All right, we're making great progress. Stay on target, and we must make all this stuff way easier to develop. See you next year.